welcome. Thank you for joining us for today's security seminar. Just as a brief reminder, next week is the CERIAS Security Symposium, annual symposium. There will be a seminar in person next week at the seminar. And if you haven't registered, we'd encourage you to visit the CERIAS website. It's not too late to register to attend the symposium. And then there is today. We are extremely fortunate to have as our speaker today, Professor Dan Shoemaker. And Dan has been working in the field for a long time. He is expert in areas of software requirements, software engineering, especially as they relate to security. He's currently on the faculty at the University Detroit Mercy, which is no surprise in Detroit. And his bio is on the website with the seminar. I'm not going to go through all of it, other than to say he has a distinguished career in helping to set standards and advise agencies as to what should be in their standards. And that is related to his talk today. So he's going to talk to us about secure sourcing of COTS products. That's commercial off the shelf. And please, as you have questions that you would like to pose to Professor Shoemaker, please put them in the Q&A, the little bubble at the bottom of your screen, not in the chat. We'll be ignoring the chat for questions, but if you want to ask something, put it in the Q&A. And so without further ado, Professor Shoemaker, welcome.
Thank you, Spath. And it's been a real honor just to be able to work and do anything with you. So here I am, and I want to talk to you today about something that's near and dear to my heart, which is, and it's something that I've been more or less pushing for perhaps 40 years. The whole field, basically, of course, software engineering is oriented towards software development and all the things that go on with the software lifecycle. I want to talk to you about something completely different today, in the sense that we're really not looking at the creation of software. I know I was teaching it back in the 90s. That was exactly what we were talking about from a software engineering standpoint. But it seemed like, all the software got made, or either that or it was all being made in India or something like that, because there's a lot less and less people getting placed in the kind of jobs I would consider to be normal software engineering positions. And that's sort of when we kind of turned our product line from software engineering to cybersecurity, which in those days was called information assurance. But I go back to the dawn of time. And the whole idea basically of the NSA Centers of Excellence, which were we were number 39. I think there's 400 and some odd now. Kind of just built around the idea that they wanted to get sort of information assurance teaching into software engineering curriculum. But that's not really what I'm talking about today. I promise I'll finish this within the time frame. What I'm talking about today is commercial off-the-shelf purchasing, which came on my radar in 2012 or thereabouts, which is coincidental with a study that ended up in front of Congress that more or less indicated that we had some weapon systems with Chinese malware in it, which, you really don't want to have happen. And so, Congress setting something that they could beat the drums about, hauled the folks in the Pentagon down to kind of slap them around about why that happened. And that led to a fairly serious effort in 2012, come up with teaching in acquisition, basically, of secure software. And that's basically what I'm talking about today and what motivated this whole discussion. So here's the agenda. First of all, let's talk about why teaching secure sourcing is important. It is indeed a very important, from a national defense standpoint, issue, because basically we buy a lot of software. And we integrate a lot of software into everything we do. And that software is made somewhere by somebody, but the question is who and, you know, kind of how much can you trust it? And then I'm not going to talk about the sky falling without trying to give you some solution here. And so basically what we want to talk about here is a process that was developed during the time I was working with it. And this was back with the Pentagon. And essentially what we're looking at was a series of standards or standard work that was happening at NIST, kind of bled over into what we were doing, which is looking at developing kind of some kind of teaching about that. And you know what that essentially is a process that hopefully can become a standard process, you know, something is sort of commonly understood, commonly accepted, commonly practiced way of doing sourcing. First of all, it's based on a standard. You know, the sort of work here, you don't listen to me. I don't know what I'm talking about. But bottom line basically is that, you know, I sit around in a room with a lot of smart people, and after a considerable amount of work, we come up with a solution. That solution you can pretty much take to the bank, since it's basically everybody's best guess about how to do it. And that's what I'm going to discuss here. That resulted in 10 principles to manage risk in supply chains, which are actually kind of interesting when we go through, and we'll look at them later on here. But the idea basically is they're quite practical and very easy to accept and understand. That you can reduce those principles into knowledge elements, and in addition to that, you can talk about implementation recommendations. That takes me back to the beginning of software engineering, because pretty much the process is defined by a single standard, which is ISO IEC 12207. If you combine these principles with that particular standard, you can come up with something that's pretty substantive. And that's going to lead me to a set of conclusions. So first of all, ideas about trust. You know, the word trust gets used so many times when you're talking about sourcing it. It's like, well, you know, if you can't trust them, what can you do? But the idea basically is ensuring that whatever you have in terms of whatever you're using, whatever you're integrating, whatever you're purchasing, take your pick in terms of the activity, is actually something that you can have confidence in. And so having confidence in the product in terms of both of its effectiveness, you know, functionality, and also in terms of its security is a very important topic. But it's a strategic topic. This is not nerd work. You know, we're not talking about looking down. We're talking about looking across, or, you know, into the worldwide. The stuff that comes up the supply chains rarely comes from, well, it could come from Redmond, but it rarely comes from, you know, the usual sources in the US. It's coming up from job shops somewhere out there where you can get people to work for 10 cents on a dollar. Office specifications, of course, you've developed, but the idea basically is that this is a global enterprise, you know, conducted amongst multiple cultures across the world at various times. And so you got languages, you got cultural differences, you got all that other sort of stuff involved in creating a product, which is essentially discrete. You know, it's real, it's you know, it's tangible, and it's not tangible, but it's, you know, it's actual, and it's you know, something that your life might depend on if it's in, say, an aircraft. My aim here basically is to show you how you can develop something that essentially teach the process. And you know, software engineering in general is an excellent field. I mean, I've lived in it for years and years. It's fun to study, fun to teach, fun to talk about. But you know, the question is how much is it really kind of you know, relevant to the current problems that we have, which again are often, you know, kind of traced back to kind of the globalness of the business. Globality, maybe I could just invent a new word. And last but not least, the outcome here is basically 4 teaching modules, which I have, and which I'd be more than happy to share with anybody that wants them, for teaching secure sourcing. And that's kind of where we're going to end up. Now, software engineering is basically about developing artifacts. It's a matter of making them without defects or as defect-free as possible, and as kind of close to specifications as possible, and a lot of this sort of stuff. And an awful lot of that is process, and an awful lot of that is a matter of kind of interaction between customer and supplier, be it internal or external. And so the idea basically is you want to be able to put together something that is useful, that the customer likes, the customer appreciates. And the software engineering body of knowledge, which I worked on back at the dawn of time, in the early mid-90s, maybe even earlier than that, maybe the late 80s. At any rate, that's kind of when we were kicking it around. It has, all of the things that are all part of your life. The things that you just do if you're in the software development, software maintenance, software anything field. And the idea basically is it's an engineering discipline. This is the definition of it, directly from the SWBOC. And I'm not going to read it to you. You can read it yourself if you like. But it's got a lot of the key words: discipline, quantifiable. And the idea basically is the application of principles to software development, to the software entity. Problem is that we don't develop software much anymore. People have people that work on it and they do that sort of stuff. And, you maybe fiddle around with APIs or interfaces or whatever. But, the major products out there that are being developed for you are not being developed, right down the street from you like they used to be. They're being developed somewhere around the world. And that's because you're talking about millions and millions of lines of code. Why is COTS such a big deal? Commercial off the shelf or government off the shelf, COTS or COTS. Why is it such a big deal? Well, nobody wants to build their own word processing, application. They just soon buy it from Microsoft or something like that. It's cheap, much cheaper, much more timely. Take your pick, even if it doesn't have everything you want, and it puts you in thrall to Microsoft Corporation. But the idea basically is that we buy it, and that's just standard business practice. And you want it when you want it. So if you want to do something, you want to download it. You don't want to sit and code it. And so the bottom line basically is we pretty much buy everything we use when we're talking about software. Problem is that where it comes from isn't well known, isn't really well understood. And all the things that you have in place at the top that says this is going to work right and all that sort of stuff that's kind of agreed on between the lawyers is, kind of not particularly useful when you're talking about a global supply chain. And the reason why is that, well, you've got this going on in different countries. And so you don't really know the provenance of your cost products. I don't know anything that I'm doing here, using right here. And for all I know, it could be full of malicious objects. Because basically, first of all, you're not going to get source, so you're not going to ever even know what you just bought. You could get the binary, and if you've got good eyesight and the patience of Job, you might actually be able to tell what the thing does. But the bottom line basically is you just got to trust the people that supplied it to you, that it isn't not going to do you in. So how is it developed? Well, it's developed out of a supply chain. Supply chains basically are just bottom to top, what do you call it? Top down, bottom up things. The design gets handed down to the bottom, wherever that bottom might be. Those little job shops develop stuff and they integrate it up the ladder to the final product. And so upward integration is kind of the way you develop software, not the waterfall. And so when you're talking about software, where it's really created is created at the bottom of the integration ladder, which might be two rungs, or it could be 7. You have a major defense system, it's 7. And you as the customer lose track of any thing that's going on, even who's actually doing the work after about level 3. And so the idea basically is there may be 4 levels down there doing something, not what, and you have no absolutely not even any idea who's doing it. It's not the sort of thing where, you outsource it to India and India outsources it to, because even cheaper in Vietnam, Vietnam outsources it to the People's Republic of China, and they do all the coding for your defense system, which, depending on how you feel about, the Chinese right now, could be, hazardous to your well-being. And so that's basically the issue. You, as a customer, have this complex device that you're kind of just bought. And that complex device is literally a black box. And so, when you're looking at this, what are you going to do about, kind of any form of security or assurance? Well, there's no commonly accepted method for doing this. And so you got the weak link. Somewhere down there in that mishmash of little shops doing the work at level 5 in the hierarchy, you may have somebody who's not your best friend. You might have the Russian FSB. In a minute, I'm going to refer to SolarWinds. All sorts of folks that you didn't know were actually involved in the supply chain. And of course, you wouldn't be able to because it's just too complex for oversight. So what do you got? Well, first of all, you can insert malicious code. That's basically what I've been implying right down the line, but you can also insert counterfeits. You do that with the hardware, not the software, but the government in particular is really interested in the idea that when they're going to buy something, that something is actually what it is. It's not something that's been, sort of with a different label slapped on it. Yeah, you can have supply chain interruptions, which is sort of the common thing. Next two things here are really just, business as usual. You've got some kind of supply chain breakdown because somebody in the integration ladder can't deliver, or you got something that basically is caused because, somebody either didn't do it right or they did it in a way that doesn't fit with anything else or whatever. And that's because, again, towards the bottom of the supply chain, you've got a lot of little suppliers doing the actual work. And last but not least, there's simple incompetence. You can't do anything about that, but it's still going to get integrated into your system, whether it was intentional or not. And wouldn't it be nice to have caught it before you actually kind of rolled the system out? And so you basically have a problem of visibility here. I think and because you aren't able to see exactly what you're, working with here, you don't have the capability to control the process from a security standpoint or a quality standpoint. So the idea basically is this ought to be a major topic in any software engineering curriculum. And it made its first appearance in 95, with the 12207 standard. Basically, they added customers and supplier kind of activities to the normal development operations, maintenance, stuff. And so the 5 primary processes, actually the 3 primary processes, make it, maintain it and operate it. Guy had 2 more added, which were sort of abstract, buy it or make it, for sale. But the bottom line basically is that from this point on, and I don't think I have to convince anybody that pretty much software is a commodity now. You got the issue of buying stuff that might be a pig in a poke. So if that's the case, then why aren't we paying more attention to what amounts to a kind of a slightly different view of the software acquisition or software creation process, which is to create it by buying it. Now, software engineering basically focuses on all that fun stuff, design, specification. That's my particular area of alleged expertise, is in specification, but the design, coding, testing of stuff, unit integration, system testing, that sort of thing. That's all taught in software engineering curricula, and taught well, I might add, but you've got all these sort of kind of supporting processes: quality assurance, configuration management, validation, verification, audit, that sort of thing, joint review. All that stuff is a nice bundle, and basically it's aimed at creating the best possible code But the idea that you have, kind of teaching about how to ensure that you're not going to get something up the integration ladder that you don't want. That's mentioned in passing. I think everything I've ever taught, I've more or less kind of at some point in time said, and yeah, there's also the possibility you could just bring it into that organization because you bought something. But, supply chain risk isn't really what everybody thinks of when you say supply chain risk. You say that around the MBAs, and they all know what that is. In fact, they live by it. Everything out there in terms of supply chains is part of MBA curriculum, but that's tangible stuff. And worst comes to worst, you can pick it up, look at it, and say, yes, it's here. I'm holding it in my hand, therefore I know it's real. I don't know anything more about it than the fact that it's real, but at least I can see it. Hold on a second. Well, that's a good question. Why is there not a standard in security for the end users? Is it political or not? First of all, you got to decide what the end user is. There's a big difference between the end users for the DoD and you. And so the idea basically is this kind of how to standardize something when you've got all sorts of potential applications of the thing. But what I'm going to talk about, if you get high enough up, you can get a standard that more or less applies to everybody. It just has to be tailored down. Okay. I don't know what I'm doing here, but that's not abnormal for me. So at any rate, the delivered product basically is invisible. I already said that. I'm not going to spend any time beating that up, but anybody who knows anything about software knows that when you buy something, you don't buy the source code because they, don't really want you messing with it. And so the idea basically is that, it's invisible, it's highly complex, and it's integrated up in, an integration ladder, global integration ladder. I think the odds on being able to kind of spot problems there are pretty much insurmountable. So, the idea basically is how are you going to be able to know that whatever you're buying is you can trust it and it's not going to do you in. So, there's really actually no thing like the question I just had, which is a good one, because basically that's the logical thing. Why don't you just teach them how to, or define in a standard basis how to do this right? But there's no, actual, the problem's too big and it's too complex, and you really can't come up with a single answer. And if that's the case, then you don't have any guarantee whatsoever that what I'm talking on right this minute isn't loaded with Trojan horses. I just got to trust that it isn't. And since I don't trust anybody, I'm pretty sure I'm probably, talking to people that I don't even know are listening to me. And that's because if you put it in at the bottom of the supply chain, it's going to go up to the top of the product. It'll end up in the product because it's going to get integrated up without any oversight. And so you can ask the SolarWinds folks if you want an illustration of that. It's considered to be the first supply chain risk management failure, but it isn't. Part of the reason why is because we don't know what we already have embedded. But the idea basically is that was a failure from an update server, that where they essentially managed to get malicious code into the update, which they then nicely integrated into updated the system with something that gave away the store. And so the idea basically is that it's not like this hasn't already happened and hit the newspapers. And so it ought to be obvious that there's some way we can talk about this in an educational setting. But the idea is that what are we going to teach them? And so basically that's what I'm going to talk to you about here. I'm not going to just raise the problem and then drop it. This is sort of what we consider to be kind of the best way to go about addressing the problem that I'm laid out here. So the idea basically is first of all, I got to understand that there are three roles here. something people don't think about much. They always think about, there's the guy that develops it and there's the person that uses it. But there's one in between there. And this is kind of you got the customer and they do all the, kind of bidding and specification development, bidding and, everything it has to do with oversight and acceptance. And you got the supplier and they do the actual work, and they should theoretically deliver a product that has no, no bugs and nothing nasty in it. But you've also got the integrators. And the thing with integration basically is, you get stuff that somebody's done for you, several people have done for you, integrated into a larger product. That's how you build complex structures. And then you pass it up the supply chain. And while you're doing whatever you're doing, you have set of fairly well-defined tasks that more or less look like simple software engineering, in terms of the building it, testing it, that sort of stuff. But the problem is knowing who you are at any point in time during the, supply chain process, because pretty much the participants in the supply chain fulfill all three roles, except at the very bottom where they're supplying but not integrating, and at the very top where you're receiving the thing, but you're not passing it on up an integration ladder because you're at the top of the ladder. So you've got everything out there who's doing, except for those two basic levels, who are doing have to adopt the best practices of acceptance, integration, and then supply, which again are well defined. But the idea-based thing is know what you're doing when you're doing it, and who exactly understand where you are in the process when you're doing it. Suppliers basically source work, and that's the simple diagram there, and integrate it up the ladder. And so if I was going to do this as one of those trees, it would start with a whole bunch of little things at the bottom, and then increasingly larger but fewer things as we work our way up the ladder. And so let's talk about these principles, which I keep alluding to. This was 12 years ago. That in the city of Washington, D.C., the people at NIST were developing something called NIST IR 7622. I sat through some of those sessions, and that's when I decided I never did want to do standards work, because there's often a lot of discussion about what the word "the" means here, but it very carefully done, very carefully designed. But the best part about it is it's got principles in it. And those of us who are in the academic business, we love principles because principles apply universally. And so the idea here is that, you can manage the sourcing process by the application of these principles. In the end, what they ended up being sort of incorporated in NIST Special Publication 800-161, which I think several of you may be familiar with, because it's the federal standard for managing supply chain risk. But the principles themselves are really useful. They didn't kind of continue on as practical advice. But if you're going to do the academic part, it's really a good basis for talking about how to source securely. 10 basic principles, and I'm going to go through them fairly quickly because I can see I'm already somewhat running out of time. And I promised you a little bit of time to talk. So principle one, well, at least find out what you got. That's really what this says. The idea basically is that when you integrate something, you have no idea what those little parts at the bottom are. They all should be labeled. I'm in this automobile stuff now, and it's called software bills and materials. But the bottom line basically is you got to know what's in it. Nobody knows what's in their stuff. They have some idea what's in, what the major, kind of components are. But we get down to the bottom, those little, units, modules that have been integrated into the larger thing, those have no identity at all. They don't exist from the standpoint of the people at the top of the integration ladder. The key word here is underwrite provenance. Knowing where it came from is a very important thing. And so, you probably would think twice if it came from people that we're currently not speaking to, like the Chinese. and while we're speaking to them, but you know, the idea basically is they might be adversaries. And then once that happens, you have to make sure that basically you control the people that are touching the stuff. It should seem obvious that you don't want somebody who is, you know, unknown or known to be hostile touching anything in your supply chain. But in order to be able to do that, you got to know who's who. And so there's something in there that says everybody, besides knowing what you got to know who everybody is, all the players are. And then that provenance, the provenance of everything, both the units that are being developed, the elements, the processes that are followed, and the tools and data have to be known. And there has to be a policy that basically says this is all got to be available and documented. And so you can't have something from 2 levels down where you don't have any concept of where it came from or, you know, what was used to build it. There's a policy that says this is all got to be recorded and understood. And then within strict limits, you share information. Who's to be, who knows what, when they know what, all the stuff that has to do with information sharing has to be well defined. And then everything that has to do with the activity involved in ensuring the sourcing process also has to be, you know, kind of promulgated, and that is done through awareness and training. There has to be a policy that says people have to know this, you know, and so, okay, we understand that we do this at level 1 and level 2 in the hierarchy, but let's talk about level 5. Are they doing the training and awareness necessary to kind of be on the same page as we are at the top? And so that has to be specified as a policy. A lot of this is policy stuff, you know, and the thing about policies is, well, they can be violated, but at least you've got the right thing to think about and maybe even the right thing to push on. So depending on how much time and effort you want to spend, you can literally, you know, have control over the process because essentially you know what you need to look at. Then, you know, modular design, information hiding, you know, that's basically the design requirement up and down the supply chain ladder. And so, again, this is something that has to be, you know, pushed down to the bottom level of the supply chain hierarchy. But on the other hand, it also is something that, you know, more or less emphasizes best practice, and at the same time is going to kind of prevent single component failures from toppling the whole system. This here is as close as you're going to get to what amounts to nothing more than simple good software engineering practice. The continuous integrator review is really important. We're not talking about reviewing, you know, the finished product or the process or whatever. What you're doing is staying on top of everybody who's doing integration. And if you're doing that, basically, you're able to ensure that nothing is being integrated that you don't want to have integrated, you know, or if it's being surreptitiously, you might, you know, they're being surreptitious about it. You might pick up the problem before it gets passed up the ladder. But that means that you have to establish actual processes to do that. You know, to perform the reviews and audits necessary to ensure that the integrators are doing what they're supposed to be doing. And from a delivery standpoint, there has to be something formal. You know, ways to basically take, you know, accept the module or whatever it is you're about to pass up the ladder. And at the same time, you know, do the delivery at the next level up in a way that ensures that everybody understands what they got and to make sure that there's no missing pieces and all that other sort of stuff that is more or less just simple inventory. You need sustainment, obviously. You know, you want to make sure that everything that is sort of developed is basically being developed in harmony with, you know, kind of the overall design and plan. And so the thing about sustainment is, you know, it kind of sort of implies change management and configuration management, top to bottom of the process. You'll get that obviously if you've got your things identified, your you know, components identified, even down to the configuration items at the bottom. And so in a lot of ways, this is driven by configuration management. And last but not least is the disposal aspect. It's funny, I don't think I've ever done anything anywhere in software engineering where there wasn't something about disposal. But the idea basically is everything it has to do with the contract has to be specified in terms of, you don't want to leave stuff laying around after you've done it at any level that might possibly be picked up by an adversary. And so the idea basically is that, how do you handle even the stuff that once you're complete, once you've completed that particular, task, to make sure that that stuff is also secure or is kept securely. And so last but not least, we come to our friend software engineering course, which is basically why you're sitting here in the first place. You can build one of these. I know that because I built one. And the idea basically is to use these 10 principles as your content teaching tool, teaching content. And get on, I think I've said that enough, but the idea basically is this is what you teach. And you can structure the actual presentation on the agreement processes, which are the 12207, customer supplier processes, and also some of the supporting processes from 12207. But 12207 meets 7622 is kind of what this is all about. This is what you get in terms of knowledge elements or what you ought to teach. First of all, there's policy. I hate to say this, but strategy and policy. And you say that to, the guys in the bottom of the machine and they go, oh no, that's just so cool, uncool. But the whole point basically is that, and this is in the standard, not my idea. Okay, this is something that folks at ISO think you ought to do. There ought to be, kind of a top-down strategy for doing all of this. And that includes stuff like how to specify the functions required, how to do the delivery, how to maintain and operate the thing, anything that has to do with storage, anything that has to do with SLAs, anything that has to do with implementation, all the really obvious stuff. I mean, some of you are looking at that and say, yeah, and yeah, we all do that. But the point basically is that's got to be part, and it's best done, I might add, as an introduction. I mean, I've done this. And so I'm saying that basically, if you want to get the student on the right track, you take that approach. And then you can talk about the actual acquisition process. The thing about acquisition is that it's got an awful lot of the business, aspects to it. How do you get all the constituencies out there to get their requirements done right? How do you find the right supplier? How do you evaluate their proposals? This is all, kind of fundamental, practical, common sense business stuff. But basically, that's what you teach next. The stuff that basically has to do with moving the thing into the org. I'm sorry, not moving into the organization, with purchasing the thing. And everything that basically is the detail of how to do all that. Again, I'm not going to read this, you can read it. But the point basically is, I think you can see that this, again, is just the simple acquisition process, top to bottom. And then you've got requirements. And if you don't do those, you're going to have a real problem, because you got to eventually issue an RFP, and that RFP more or less guides everything you're going to do in terms of your evaluation processes. And so you get the requirements right and get it into a proper RFP. And a statement of work accompanies these. But this is really a different aspect of the thing. You got a good statement of work to go along with your requirements. You've got a basis again for kind of passing that down on the supply chain to the appropriate level to be executed based on your defined kind of requirements for the work report. Then identify the suppliers. This is kind of your strategy for finding out who to kind of issue the RFP to, and basically get them to kind of respond to you in a way that's intelligent, so you can do the proposal evaluations. Here is the old-fashioned quality and security requirements and service level agreements that go along with basically the negotiations that you have with the contractor. Then we have the part that says, and if that doesn't work out, how we turn this over to the lawyers. But I mean, you got to think of everything. And this here really, again, is a business process. The proposal evaluation is, kind of the thing where you bet the people are going to provide what they're going to provide. And this isn't just the prime contractor. This is all the way down to the bottom of the ladder. And so, you really got to have to get to know your suppliers in the supply chain. I know this takes extra work, but it keeps you from getting little surprises. If you don't know that. And in the end, what you do is you negotiate the contract based on all that knowledge. Okay, and then you keep an eye on things, and the whole point basically is you got a well-defined set of requirements in terms of what they got to do and who's got to do it and when and where and how. And so you got a basis for oversight. And, you may even want to approve each work segment as it comes along, because basically you're looking at integration. And when you got integration, you got an opportunity to catch things as they come into the process to be integrated. And so this is really like those sort of little quality checks they do on assembly lines before it moves on to the next, assembly line, the component that is. And, something that has to do with making sure that, the vendors are managed in a consistent and rigorous way to ensure that they're all marching in formation. Then how do you certify? This here is the, part where you have some kind of acceptance testing, and this takes place at all levels. I'm not just talking about, where you have the grand acceptance. This takes place whenever it gets passed up to the next level. And so the idea basically is at each level here, you've got something, and you're, as the customer, if you're, or the great, grand master of the supply chain, sitting over them more or less saying, is this something that you can accept and then move up? But that's going to prevent you from getting something nasty from the level below you, because you essentially have a formal acceptance process for each time, the thing transitions up the ladder. That doesn't really happen much. But if it, that's, if you want to catch stuff in a supply chain, that's the only way you can do it. And so, this is keeping the records. How well do they do, as suppliers? And this is for future reference, because obviously, next step in the process is have the same thing going on with the supply chain, the next supply chain. And, how do you basically ensure that the suppliers you're dealing with are the ones that, you want to be able to be dealing with? And so the idea is that, this is sort of the grand finale, but the point basically is that this is where you kind of wrap it all up and keep it as what amounts to institutional information that you can then access later on, should you decide to do something else in terms of either a new contract or new product or whatever. And this is basically is what this looks like. I know it's an eye chart, and so it's not anything that I expect you to be able to read, but I imagine they're probably going to provide this in some form. And these are everything I talked about in terms of practices in modular form. And basically you present them as 1, 2, 3, and 4. The idea basically is that this takes those, what I just talked about, and turns them into a set of teaching topics. And it more or less pulls this all together into a single homogeneous kind of presentation strategy, teaching module, teaching process. That's it, teaching process. So in the end, you got both a structure and a direction for teaching this as a defined area of study. Meaning this isn't really development, it's not really a waterfall, it's not really the life cycle. This is something else. And so essentially it's a separate course. And you can teach that course based on what I just presented. You may not be ready to do it as a complete course, I might add, because this is really, I've been doing this for years, and I understand for some people, this is something they're just hearing about today. But the idea basically is that, if you're teaching something else, you can talk a little bit about some of the supply chain issues, particularly the things that have to do with acceptance an integration and acceptance. Partly because that's part of the standard, lifecycle development process. And so the whole point here, though, is basically is to get this into a unified presentation. It's best understood if you teach it as what it is really, which is a separate activity in the software engineering, kind of pantheon of skills. And so it sort of begs for a second course. So one option is a capstone, or a single course, which is the way we do it. We offer it as a single course called I don't remember what, secure acquisition, which is really not quite as fancy as secure sourcing of COTS products, but you got the considerations that you have of your university catalog. If it's an undergrad course, you're really talking about the nuts and bolts of the 9 topics, meaning you just teach that stuff, not necessarily teach it in the big picture. But if you're going to move on to the graduate level, really got to have to talk about this as implementing it as a unified approach. It really is a coherent strategic process. And so the whole point basically is to understand the process and be able to apply it, or if you're the teacher, be able to communicate it to the individuals out there, because they really got to understand that they're going to have to, go through the processes that we've just talked about in order to be able to say with certainty that, their supply chain is free of kind of things you don't want to deal with. And so here, my aim here basically is I just want to, kind of talk about what the problems are, the integration problems are, the whole security problems are involved in developing something in a highly diverse, multicultural, multilingual environment that is going to be trustworthy. But if we don't do something about this, then it's going to be very difficult to trust any of the purchase code we got, because it's just too obvious that if you really want to own somebody, all you got to do is put some stuff in there, kind of products that you're going to be using that will allow you to own them. And if I figured that out in my own, humble little way, I can't imagine what's going on in some of the countries that are real adversaries of ours. I know that's been a favorite topic with the FSB because they've already pulled off a major supply chain hack. Bottom line basically is we're going to have to do something about this, or, suffer the consequences. And that's basically what I had to talk about today. So that's me. And I see that I've got cool Q&A bubbles here, so I think I'm going to try to answer whatever you put in here. Microsoft, Passkey, management, supply chain, device managed software. Are you kidding? I don't know. Don't outsource it. I mean, I'm not what do you call it, privy to what's going on with the Microsoft folks. But the bottom line basically is if they're integrating anything from outside, I sure hope they have some concept of what the provenance of those things are, because like I said, it's just way too obvious. And who you're going to attack? We're going to attack the thing that opens the door. And so, are they doing it? Well, it's also business, and you want to make the maximum profit. And so my guess is they aren't, but I'm like I said, I'm sitting here in Ann Arbor, Michigan, not Redmond, Washington, and I have no idea whether they're actually doing what they should be doing. What I'm talking about here is sort of like kind of gospel. The actual sinning, that's up to them. And it's difficult not to be a sinner. And I suspect, knowing what I know about Microsoft, that there are a number of sinners there in Redmond, Washington. Wow, that would be great. There's certainly a way to easy enough way. Those principles basically apply across the board. Now you've got a complete standard in the 161 18161 standard. 181 is nice. Well, the 161 standard. And so, you've got a lot of clear paths laid out, but you got to remember, I did a lot of this when I was working with DHS with bailed security, and I went down to Ford and with stone tablets on my shoulders, and we had software assurance nailed. And they had people calling in from all over the world, and I did my little thing. And yeah, at the end of it, I said any questions, and this guy, I'm not going to use the word he used, but um, you know, uh, front row raised his hand and said, "Everything you said is bull. That's not the way we do it here, and nobody would want to do it that way." And it's like, yes, sir, I agree. You know, if you're not willing to do it, and people complain like crazy when you add, additional things like we're talking about here, to what they already have to do, then you got an issue. I think the Pentagon basically is the only place I know of where they've got a real issue, first of all, they got the leverage because they got the money, but they, kind of can sort of move the ball down the field a little bit because they, kind of have a lot at stake in not having malware in their weapon systems. The thing that got that kicked off was the P-2B Orion, which is a submarine hunting airplane. And when they were looking at that stuff, they literally found Chinese malware in it. And like I said, that set off a whole lot of, kind of congressional investigating back in 2012. But I mean, the bottom line basically is people have to be willing to do it, and it's overhead. If you do all that stuff, inspecting, all that sort of stuff, it's going to cost them, and they don't want to spend the money. So you can pay me now or pay me later. That's sort of my view. But nice thing about being an academic, I don't have to make them do it. If I did, it would involve whips, I think, probably because that's the only way you get them to respond. AI to me is, again, those of you know what, it's basically training the machine, and so you really have to have a basis for the machine to be, to kind of detect what response is appropriate. And I hear that word and I mean I can spell it. But I don't know what people are thinking when they use a word like AI. AI for them is some magic box that, would do, does all the things that we can't do as humans. And, when you're talking about COTS software, you got people out there who are more or less know that you don't, I mean, I hate to sound like I'm wearing a tin hat, but, if you've gone through 2 outsourcing steps, you don't know where the product's being developed. 3 outsourcing steps. You got the supplier, and then you got the prime, and you got the subprimes, and then you got probably their, kind of the people, and then after that, it's unexplored territory. And so if they want to, kind of outsource down to the 4th, 5th, and 6th level, you have no idea where it's going, what it's doing. AI isn't going to be able to help you out. It can do anomaly detection, but you got to know what anomalies are, what the anomalies, what would be an anomaly, have enough of a baseline to know what anomaly would be to be able to kind of develop any kind of AI response. And so in general, this is a process problem. And it's also a hearts and minds problem because you're going to have to get a lot of folks who don't want to do any of this, to kind of say, oh yeah, okay, we'll try that. And so that's kind of my response is AI is not going to save us. The only thing that's going to save us is going to be getting our act together, and then more or less doing the right thing, which is a lot to ask American business, where profit is pretty much king. And so, do you want to answer this question live? I don't know what I'm doing here.
I've been checking that, Dan, as you've answered the questions. I've been checking them off.
Okay. Well, I guess I've answered the questions. Anybody have anything else? Or anything that anybody wants me to talk about? I've still got 5 minutes here.
I suspect we could come up with a long list of topics, but I think that was a nicely organized presentation of how we should approach this. Um, and if we don't have anything else show up, we'll let everybody get away a minute or two early. Thank you so much, Dan, for joining us today. That was a wonderful talk, and an area that I think we need to put a little more attention as we further develop our global markets.
Well, it's my honor to do anything with you, Spaff. And you've always been the man as far as I'm concerned. And so,
Well, I hope we get you to visit in person sometime, and
hey, I'd love to do that. I really would.
that'd be great.
And sometime when the weather's nicer, okay?
Yes, that's a great idea. And for everybody else who's on the call, again, as a reminder, next week is the CERIAS Symposium. If you haven't registered, you still can. Anybody who has an email address that ends in .edu can register for free. We have a great lineup. The agenda is on the CERIAS website. There is a seminar next week, but it's live. And with that, let me wish everybody a good remainder of the week and a pleasant Easter weekend if you celebrate that. And we will see you all at a future seminar. So, and thank you again, Professor Shoemaker.
Thanks, Spaff.
Bye all.
Bye.